You'll also notice on the main RF editor window what appears to be tracks very similar to what you might have seen if you've ever used a video or music editing program. And in fact, these are exactly that. They are time tracks that allow you to very precisely position individual waveform segments in the time domain such that when you build a new waveform, you have the ability to precisely locate them, referencing one another's starting and end points, perhaps now then combining them in the frequency domain so that what used to be recordings of individual modulated carriers now appear in a single spectrum capture file as a multi-emitter, multi-carrier waveform without having to construct that from scratch. So as an example, I have three different WiMAX signals, one at 1.951, one at 1.962, and one at 1.973. This was our dual carrier version. And I'm going to go ahead and drag each one of them into a time track. Let's go ahead and change our time span here. So this is 10, the time scale is 10 milliseconds in length. You can see I can do that very easily through the time scale windows and align them such that the one at 1.951 starts first but then is overlapped for a brief period of time by the one at the slightly higher frequency, and eventually the third carrier will come into play. Now notice I haven't been very precise, nor did I need to be very precise in terms of where this lays in the relative time domain, because I can go ahead and call up the specific details of where on the time track it starts and where it ends. Let's say for a moment that I actually want this file to be longer in duration and start earlier such that it does in fact overlap the one single carrier at 1951 and the single carrier at 1962. Well, in order to do that, it would actually have to start somewhere at approximately 1 millisecond or so, or a little bit earlier. So let's move this instead to begin at 0.5 milliseconds. I don't want it to maintain its width. If I maintained its width, it would simply slide the entire thing, but I actually want it to be stretched. So if I apply that, it does in fact move the beginning point to 500 microseconds or 0.5 milliseconds and stretch the length to accommodate its original endpoint. Hit done. Build a new RF waveform now by adding these three, stacking them in the time and frequency domain, specifying a name, let's call it multi-waveform. Clicking OK, RF Editor builds the file, and when it's sent to SpectraX, it's automatically loaded, and if I start to play from the beginning, there's the first carrier that I had specified, the 1.951 megahertz carrier. Continuing the play, the second set of carriers, the dual tone frequency carrier, remember it started then at 0.5 milliseconds, and you can see here from the relative time domain, this is in seconds, so this is 1 millisecond here, 0.5 milliseconds starting here, and then that will play for a while, and finally the third carrier will show up of the three that I had staggered relative to each other in the time domain. So a very, very rapid way of taking individual segments that contain some of the information that I want, some of the spectral content that I want, being able to very precisely align them in the time domain, build the new waveform, and then by linking it to SpectraX, visualize the final result and perhaps tweaking it even more.